everybody, and welcome to this video on the 2020 GDE Prelim paper. In this video, we're having a look at question 10 on the applications of calculus. So here we have a diagram represented below of a graph y is equal to x squared and a rectangular Pqrs. And then it says P is a common point on the graph and the rectangle, and the graphs of y is equal to 6 and y equals to 0 represent two adjacent infinite lines of the triangle Pqrs. The coordinates are 6 and 0, and P and Q 6 minus x and 0 are given. So there it is all in the diagram, and it says that we should calculate the coordinates of P in terms of x. Now, first of all, having a look at the coordinates of P, we can see that the x coordinate of P is the same as the x coordinate of Q, which is 6 minus x. The next thing is we'd like the y coordinate of P. Now, think about this carefully. We won't be able to use S to get the y coordinate in a similar way, but we will be able to use the fact that P lies on the parabola to get the y coordinate. So the equation of the parabola is y is equal to x squared. So to get the corresponding x coordinate, we say y is equal to 6 minus x squared, which is 36 minus 12x plus x squared. Therefore, the coordinates of P is 6 minus x and 36 minus 12x plus x squared. Now let us have a look at the next question. It says that we should determine the maximum area of the triangle PQRS. Okay, so before we get the maximum area, let's first get the area as an expression of x. So the area of a rectangle is length times breadth, and we can say that is then it's been like QR times PQ. So the length times the breadth. Okay, so now for QR, because we know Q and R are on the same line and they have the same y coordinates, we know that their distance is the difference between the x coordinates, which is 6 minus x. So for PQ, we're going to do a similar thing. We're going to subtract the y coordinates because the x coordinates are the same. It's a vertical line. Okay, so now we simplify that. What we get is x times 36 minus 12x, sorry, that should be a plus x squared. Then we can distribute, we get x times 36 minus 12x plus x, oh, sorry, we're distributing, I'm writing the same thing again. So it's 36x minus 12x squared plus x cubed. That is the area. Now what we'd like to do is find the maximum. So to find the maximum, we take the derivative with respect to x. So that is 36 minus 24x plus 3x squared, and we equate it to 0 for minimum or maximum. Okay. So now I'm going to divide everything by 3. So we get x squared minus 8x plus 12 is equal to 0. And then the factors of 12 that give us minus 8 is x minus 6 times x minus 2 is equal to 0, telling us that x is equal to 6 or x is equal to 2. Now, one of these answers will give us a maximum and one of these answers will give us a minimum. So if x is equal to 6, it means Q is basically on R. So this here would give us our minimum. So that means the correct answer is for x is equal to 2. So we would now like to get the area. So using the formula, the maximum area, so we've got that the area's formula is 3x minus 12x squared plus x cubed, and now to get the maximum area, we substitute the value of x for which it has a maximum, so it's 36 times 2 minus 12 times 2 squared plus 2 cubed, and then calculating that, we get that the maximum area is then 16 square units. I hope that you've understood this video, and please watch the rest of our series, and thank you for watching. Bye.